Hey you! Bored of being stuck on Earth? Fed up by the fact that you can't explore new frontiers in space? Well, now you can with a new and improved, magnificent, spectacular, life-changing invention, the Photobioreactor.
Okay, enough of that. It's actually not as unbelievable or science fiction as it sounds. It actually exists. Before I explain what a photobioreactor is, let me explain a bioreactor. Simply put, bioreactors are a type of apparatus used to grow organisms as they provide an ideal environment, similar to its natural one, in order for those organisms to function. Think of how seeds grow in soil. There are many different types of bioreactors, however, the specific ones currently being explored for its use in space are photobioreactors. These particular bioreactors are powered by light. Basically, what a photobioreactor does is that it uses light to nurture phototrophic organisms. These are organisms that make their own food using light as their main medium. In order to use light, it requires additional help from another source, such as algae. Algae is highly sensitive to light and has the ability to perform efficient photosynthesis. So the working of a photobioreactor is actually quite simple. Algae in tubes are directly exposed to light and carbon dioxide is taken in via a valve. The ideal environment for photosynthesis is maintained using various sensors to control temperature or even pH levels, such as sensors like this. Now once photosynthesis of the algae is complete, oxygen and biomass is created, which exit through these valves and can be used for various purposes. Now I'm sure many of you future astronauts out there are curious on how this cool invention is used in space. Well, I have 4 words for you. A hybrid life system! This could potentially help towards sustenance in space for long durations. We already have something called the Life Support System, LSS for short, whose fundamental purpose is to convert carbon dioxide into oxygen and water using the Sabatier process. The first step of the Sabatier process is to decompose water through water electrolysis. This allows us to separate water into hydrogen and oxygen gas. The hydrogen gas collected will then be mixed with the carbon dioxide present in the atmosphere. This reaction is exothermic and requires a nickel catalyst in order to speed up the reaction. The reaction looks something like this. So as we can see, the Sabatier process generates drinkable water and methane, which can be used to power the rocket propellant or in the heating of substances. The integration of the photobioreactor and the LSS will result in a hybrid life system. The photobioreactor will use a surplus of the highly concentrated carbon dioxide of the LSS to produce oxygen and potentially edible biomass. Having an integrated life support system, astronauts can get the much needed oxygen and protein-rich food from it. This will make sure space programs can be longer, more cost-effective and allow for greater exploration.